Association. This is the association of 11 tire companies that make on-the-road tires here in the U.S. This is our third in a series of webinars featuring perspectives from diverse experts and visionary leaders who are driving innovation and developing powerful end-use markets in the field of tire recycling. Tire recycling is a pillar of sustainability, innovation, and economic growth in the U.S. According to the USTMA's 2023 End-of-Life Tire Management Report, tires remain one of the most recycled and reclaimed products in the country at 79% at that time. But end-of-life tire generation continues to outpace recycling and consumption into end-use markets. We believe a powerful solution is the expansion of ELT markets like tire-derived aggregate, molded and extruded products, and pertinent to today's topic, rubber-modified asphalt. Expanding markets for recycled tire products not only leads to better ELT management, but also creates substantial economic and environmental benefits, including raw material savings, landfill diversion, and emission savings due to repurposing materials. In this series, we're addressing the benefits of ELT recycling and providing actionable steps and resources. We want to spur action among policymakers, DOT and municipal leaders, civil engineers, recyclers, and others across the broader tire value chain so you can apply lessons learned and advance ELT management in your own markets. On today's webinar, we'll be discussing rubber-modified asphalt, which has been used in the United States since the 1960s and shows demonstrable performance, economic, and environmental benefits. Here with me today to dive into the ins and outs of this market are 4 PhD experts on rubber-modified asphalt. Dr. Redmond Clark, the CEO of CBL Industries and founder of Asphalt Plus, a dry process ground tire rubber additive. Dr. Bill Butler, the founding director of the Missouri Center for Transportation Innovation at the University of Missouri, Columbia, Mizzou. He also authored our USTMA Rubber Modified Asphalt State of Knowledge back in 2021 and a summary of state specifications for RMA. We have Dr. Carolina Redesno, the Associate Research Professor at the National Center for Asphalt Technology, recently published Development of a Framework for Balanced Mix Design and many other works. And we have Heather Dilla, the Vice President of Sustainability and Innovation at Construction Partners, Inc. This is a vertically integrated civil engineering firm in 6 states, and they have 45 hot mix asphalt plants. Heather was previously with FHWA, National Asphalt Pavement Association, and Black & Vetch. Please note that we plan to address audience questions at the end of this session as time permits. We ask that you use the Q&A feature in this webinar to submit your questions for the panel throughout the discussion. And finally, we'll be making additional information and resources available to all attendees in a newly created Knowledge Hub on the Tire Recycling Foundation's website, www.tirerecyclingfoundation.org. So without further ado, as Lucy Van Pelt might say, the doctors are in. So let's bring the panel into this discussion and examine the business case for rubber-modified asphalt. Bill, let's start with you with a 2-part question. Can you give us the national snapshot on RMA? Where is rubber-modified asphalt being used successfully today? And from your perspective, where is adoption headed?
Yeah, well, things have really come a long way since the early adoption. The early adoption was kind of wild, wild west. It goes back 30, 40 years ago. People were chopping up tires and not grinding them very fine and just trying them in pavements and in asphalt. Got a little more modern in the 1980s and 1990s with you got to distinguish between wet and dry process. So you saw states like Arizona and California making very specialty surfacings for asphalts with that wet process. And wet just means that you're liquid mixing the liquid asphalt binder with the ground tire rubber. I call upstream, so before the contractor ever gets it. But what's really come on in the last 20 years is the dry process, which maybe a little more contractor friendly, certainly more cost effective. And that allows the contractor to put a dry feed right at the hot mix asphalt plant of the ground tire rubber to make rubber modified asphalt. So, we did a state specification summary just a couple of years ago, and it's gone way beyond just those Western states where some 21 states have publicly available specifications posted on their websites. At that time, only about 4 had dry process specs that you could find publicly available. But since then, I would say that number is probably more like 10 or 12 that either have them and they're publicly available or they will be soon. And so both the wet process and dry process have caught on. But then again, that's still just about half of the country. So there's still a massive opportunity for other states that haven't tried it to get into it. So we'll talk about that later.
And what is the significance of these specifications? Why are they important?
If you're a contractor, that's sort of like the the recipe. That is sort of the how you design and how you get paid and what you have to do for quality and for compliance. And so contractors would be pretty nervous to even try a project if the owner agency, like a state highway agency, didn't have a specification. It gets everybody on the same page. It gets you doing things right. So I would say it's really an important step, even if it's a provisional specification that's maybe been tried and true in another location. That's good enough to get started, but some kind of a decent specification is critical. The other thing is investment. There's a little bit of investment. It's not massive, but those contractors will be more apt to make the investments in, let's say, a dry process feeder system if they know the state is serious, and they know they're serious if they have a spec.
We also have seen that counties and local governments rely on those state specifications and either look to them wholesale or adopt directly from them. This is Red Clark. RMA has been validated as a beneficial end-use market and is in a strong position for growth. What's your view on what's needed to expand this market? You're muted.
Sorry about that. To follow on Bill's comments, the starting gate is simply getting permission to use the process, and specifications are going to be an important element in that. Once the specifications are issued, the contractors have to develop a plant capacity to make this product. They can't just throw the material into the drum and mix it up. So they need a loss and weight feeder or a loss and weight silo in order to put that material in. A number of contractors nationally already have that capability. The others, need to look at an investment. Now, when contractors, again, as Bill had indicated, when contractors step up and say, okay, I'm going to consider using this material, and okay, I have to make a capital investment in my plant in order to make that work, they need to see an opportunity to make a return on their investment, ROI. Typically, what they like to see is a specification that allows them access to big volume projects. Those are parking lots. Those are typically going to be large highway projects. They get their return very quickly if you can save money with rubberized asphalt, which you can, and if you're in a big enough project so that you can put a large volume of material through the feeder. Now, the DOTs are going to issue a specification as long as they have a substantial body of information showing that it works. And they have to have a value proposition, meaning that you have to save money and or you have to make pavements last longer. Those are core in order to create that business opportunity. So if you want to expand the market, we have to get that information assembled. We have to put it into the hands of the DOT and the contractors, and then we'll see expansion that will follow behind that. This is a low bid industry. Everybody wants to find a way to make their mixes effectively but less expensively whenever possible. So once this breaks through with the specification and plants start to use it, the market has an opportunity to grow from that point. Bill indicated that the DOTs need to make a decision on issuing a specification. The contractors, if they see an opportunity, they can be instrumental in convincing a DOT to work on a specification sooner than later. So this is a dynamic partnership that we're all working on.
Yes, the contractors are an equally important partner in pavement development, pavement management in the United States. Heather, let's bring you in from a contractor's perspective. It sounds like there's capacity out there for contractors to scale rubber modified asphalt as demand continues to rise.
Yeah, and I would just reiterate, what we've heard from both Redmond and Bill, that from a contractor's perspective, there's really two concerns that we have in adopting any new innovation that's not just specific to ground tire rubbers. So one is, what is that operational risk? So the operational risk, as we mentioned, does it change any of our processes? Does any of our existing equipment need to be changed? Or can our existing equipment handle whatever we're putting in and adding? And then can we still meet the specs and protect those pay factors? So we're looking at, what's the quality of our mixes and making sure it's not variable, throughout as we run it through our plant. And I think really the encouraging thing and what you've heard today is ground tire rubbers come along, or heard so far, I should say, and hopefully we'll hear more about, it's come a long way. So Wiregrass Construction, that's one of our subsidiaries in Construction Partners Incorporated. They operate in the southeast of the United States. We had 2 completed pilot projects in Alabama where we used that dry process. And in that dry process, we had no issues running it through our plant, no operational issues, and all of our pay factors were met. The second concern is related to our customers demanding it, right? Like, do the current specifications allow it, and is it competitive? So in that comparison, or are they specifying it? And in the current states that I operate in right now, there aren't any specs for that to my knowledge, but what we had were pilot projects in that case. And because there were not any real specs that to follow, what we used was balanced mix design in that in those projects. And I know Carolina, she knows more about that because she did a lot of the testing on some of those pilot projects for us. But that was very important for us to make sure we're meeting both those rutting and cracking performance. But I really see that there's an opportunity, and you ask, what can we drive forward as DOTs move towards adopting balanced mix design, which I think several are. This creates that level playing field for innovations such as ground tire rubber, because now we can start highlighting the performance benefits as well that it can offer. So that's, in my view, where we need to be moving forward if we really want to see some of these innovations going forward. And to Redmond's initial comment, getting large projects, you can get some large projects implementation through that adoption.
Thank you, Heather. Really nice transition here. Carolina, let's hear from you. I want to talk more about RMA specifications and what's changed about the specifications that might be a key to helping states adopt RMA more quickly.
Yes, I would say that agencies are recognizing the importance of performance-based. You can call it performance-based, you can call it balanced mix design, because when you are dealing with performance-based specifications, you are opening the door for innovation, right? You don't have the limitations that we have currently with volumetric design. So when you open that door, it allows innovation that otherwise would be a little more challenging to support. For the case, for example, the case that Heather was discussing previously, we have been working here in Alabama and several other projects, not just the 2 that you mentioned, Heather. And those projects have been sponsored by the Alabama Department of Environmental Management, where contractors were actually producing mixes with dry rubber, but we were relying on a special provision with balanced mix design that was developed by Alabama. So we help the contractors, just to ensure that performance-based results that they were getting, and we are now in the process of monitoring the performance of these sections. I think it's important that you don't only put it down, but monitor it over time. And the goal for these projects using that provisional specification is we are always sort of trying to compare these rubber modified mixes with control mixes that don't have any rubber, that will be designed using conventional superpay design. Otherwise, it's hard to assess what is the impact actually of adding the rubber if you don't have that control section side by side.
Right. You emphasized just before we went online here, the time element that's involved in the data that's in the collection of the data. In a lot of fields, it's cause and effect, and you see it very promptly. In asphalt pavements, you might not see effects for 5, 10 years down the road.
Yeah, well, 10 years will be relatively good. I would say sometimes if you have a bad product, you can catch it even sooner than that. But yeah, typically you are going to have to wait several years. And that sometimes, like I say, agencies get excited. They put sections down. They don't monitor the sections. They don't know what happened to the sections. So it's important as you think about expanding the use of these technologies to understand that if you want to learn about these pilot projects, there is going to be a process involved when you actually are paying attention to what's happening to those sections.
Thank you. Red, you've done a tremendous amount of work in this area, and I'd like to turn to dry versus wet processes. How does an advancement like dry process RMA change the conversation with state agencies as they're developing specifications? And what kind of data have you found most useful to provide the DOTs to help get a spec in place?
Well, before I get into a detailed answer, I would just like to emphasize that if you think that economics are not intimately involved in these decisions, you are mistaken. We're going to zero in on this over and over again. The cost of these mixes in a low bid environment is critically important. So you got to try to find a way to make these mixes not only greener or more sustainable or operationally capable, they also have to show some kind of a benefit. Now, wet process rubber, which is adding crumb rubber to an asphalt binder, processing the binder, and then selling that binder as a mix additive, it didn't grow into a huge market in the United States. It was mandated by the Federal Highway Administration a number of years ago, and the mandate failed because it was too difficult to use. But far more importantly, it was more expensive than other alternatives involving synthetic rubber additions to asphalt binders. So higher cost technologies aren't going to do well in this environment. Dry process was an invention that attempted to address the economic shortcomings of wet process without compromising the quality of the pavements. Okay, it's simpler for the contractors to use, and all they essentially do is add a treated rubber into their mix plant while the mix is being produced. Okay, it's less expensive than current practices, and that creates an open door, if you will, to allow the process to move forward. And we already know that rubber additions improve pavement performance, but dry process rubber gives the industry what we call value propositions. And the two most important are you can reduce the cost of heavy traffic pavements by using rubber in place of polymers. Secondly, for unmodified asphalt, standard asphalt mixes, you can extend the life of the pavements by adding rubber. Okay, you can also add polymer to those pavements and extend the pavement life, but polymer is more expensive. So we have value propositions where we can improve performance or maintain performance at a lower cost. Now, when you go to a DOT, that's the starting point, is to say, hey, we have value propositions here, and that gets you a sit down and a listen. But as you've already heard piecemeal, I think, the DOTs want to understand not only the value proposition, they want to make sure that it's going to work properly. So we've been working for 25 years now, putting down test pavements on larger and larger projects and observing their behavior over 5, 10, 15 years. And we have data that we can share with the state showing that it does in fact provide benefits to pavement performance. The states also want to see evidence of other state specifications. They want to see evidence of contractor adoption. As Heather pointed out, look, I need to know that this is going to go through my plant. Well, this technology has gone through hundreds of plants in hundreds upon hundreds of projects, and we're not having any problem at all operationally, which tells the DOTs this is going to work from that perspective. The DOTs also want to understand that they can control the quality of the product that is being produced. And so there have to be quality control processes that exist and have been proven in the field that allow them to monitor production and make sure that they're getting a good quality mix. And finally, they love to see the reality that they're not the first agency to try this out. We have agencies that have issued specifications now going back more than 10 years for dry process rubber. And as a result, other agencies can use their specifications as a starting point to develop their own. Now, dry process rubber is delivering all that information to the DOTs, and you would expect that specifications start to pop up more frequently as a result. And as Dr. Butler indicated, that's exactly where things have gone. So dry process has been sort of a game changer because it's answered all the shortcomings of the earlier rubber modification processes.
That's right. Bill, what are the biggest changes you've seen, both technically and institutionally, that reduce the risk for first-time DOTs, particularly as they look to scale beyond a pilot phase?
Yeah, I'll just kind of piggyback on what Carolina said. We now have, and this is probably just the last 5 years, in a lot of states we have balanced mix design, and so think of it as maybe the extremes of the spectrum from high temperature, where you might be considered with rutting and permanent deformation in the pavement, to lower temperatures where you might be concerned with cracking. And so you can really see in the rutting test what's going to happen in the field. It's not a one-to-one correlation of rut depth, but it's not bad either. It's a pretty conservative test. So you make your rubber modified asphalt after the mix design or as part of the mix design, and you run this wheel tracking rut test over it under really warm water. And it evaluates both rutting potential, where these rubber modified mixes barely move in that test. So that gives you this really good feeling that, okay, we're not going to have a rutting problem or a moisture problem, because that test also looks at moisture sensitivity. Or you could run a second moisture sensitivity test as well, and these mixes do well in that. And then on the other side of the spectrum, you can see how you're going to do with cracking. And a lot of people look at intermediate temperature cracking tests for kind of intermediate temperature environments in the U.S. And you get up into the northern states, and I've worked a lot there, they'll use maybe a low temperature cracking test. And the rubber modified asphalt, especially in that low temperature cracking test, really shines. And then those are meant to translate to performance. So they have certain scores in those tests that you hit a score for a certain class of pavement, certain amount of traffic, you're going to avoid the rutting, avoid the cracking. And so that's really a game changer for really any new product you're trying to introduce into the market, but especially for rubber. The other thing is just the loads of field data that we have. So it's not only like the total pavement score in terms of its quality or its serviceability over time. We've been tracking that, like Red said, for over 25 years, even for the newer dry process. But like skid data, so you pull a skid trailer across pavements and you show that you have, in many cases, enhanced friction because of the coefficient of friction between rubber on rubber is quite high. And so you can see some benefits in stopping distances being shorter, safety, and just roughness index. It maintains planarity, so you have a lower international roughness index, or just smoother pavements longer. And there's other things you can measure. You can measure noise coming off the pavement, which is lower with rubber modified asphalt, and some other things that owner agencies may or may not measure, but have been done around the United States. So I think those are all risk mitigators.
Thanks, Bill. Heather, what's an adoption driver that you're seeing?
It's funny that what Bill said, because I would echo exactly what he's saying. And from a contractor's perspective, I think the movement towards these performance-based specifications is exciting for us, because we're moving away from the traditional volumetrics, which is like a recipe based, just add these, quantities in, to where innovation can flourish. And so I think it's encouraging contractors to start experimenting, right? Or start trying different mix design, which then gets them interest in additives such as ground tire rubber. What does that look like? What competitive advantage can we gain with this material? So I echo exactly what has been said by the previous speakers and think that that's one of the biggest drivers. Of course, there's other, circularity from the sustainability that's certainly a benefit in certain areas. But I think it's more out of this movement to, can we get some innovation into the design process of what materials we supply to the agencies and truly get performance-based specs that can tease out those benefits.
Thanks. Bill, let's look at this from the other direction. What would be a barrier that's still in place today that you think more states should look to remove in 2026 and on into the future?
If you haven't done a recent demonstration project, you probably don't have a spec. If you haven't tried it, I implore you to try it, because you're going to enjoy the process of the mix design. The production you're going to see is really straightforward, the construction, and then you're probably going to love the results that you get in the field. So I would say, if you haven't done a demo, just start with that, and you might even talk to your colleagues in surrounding states, or talk to anybody on the panel here, and we can point you in that direction. Probably could support you for that matter. And then, but if you have done a demo but you don't have a spec, then I would say, kind of formalize that specification, because there's some out there, some of that are even being published, that you can take and modify to fit your verbiage for your state.
Let's talk about the return on investment for rubber modified asphalt. Red, you think about ROI as a two-sided calculation, right? For producers, they're looking at the payback on capital versus mix and labor cost changes. And for owners, they're looking at value versus unmodified mixes, which depend on a bunch of varied factors. So how can the DOTs balance these needs and get technology adoption moving forward?
Well, that's a great question, John, and it's slippery, because we've already discussed, at least with a little bit of specifics, we've discussed some of the benefits that rubberized asphalt can bring to the paving community, but everybody wants those savings, right? The DOTs want to recover those savings from the contractor, and the contractors need those savings in order to afford to to pay the capital costs and the operating costs for the new equipment that they have to put online. So in a low bid world, those needs are in conflict, right? They both want the money that's there, and it needs to be spread around in order to get both sides moving in the right direction. But if the DOTs open up their specifications, one thing that they can be assured of is that over time, as the practices like these get adopted by the rest of the paving community, competitive bidding, low bid, means that those benefits are going to be handed back to the DOTs, less the true costs for the contractors. So the bottom line is that they may be in conflict up front, but the DOTs, in my opinion, need to kind of step back, ease back a little bit, and recognize these numbers are simply going to come back to them in a few years once practice becomes standard in the industry. There are other benefits that don't necessarily immediately show up on a low bid approach, and that is that if we can diversify our sources of supply, so instead of just buying one particular polymer, okay, you have an opportunity to put crumb rubber in its place, and there is going to be some cost efficiency that you'll recognize there. But rubber is in a very different supply situation compared to polymers, because there is an incredible amount of rubber out there, tire rubber out there, looking for markets, okay, relative to this industry. So if the industry is strategic in its thinking, including elements like this in their supply chain, mean that there is going to be a greater degree of price stability, and there is going to be a greater degree of price predictability over time compared to traditional manufactured products that go into the industry. In the end, the adoption of a properly vetted new tech like dry process rubber is going to help the entire industry meet the goals of all the players. Okay, the DOTs need to kind of look at this and recognize, okay, we need to open up the doors, allow this in, not mandate it, but simply allow it in and let it compete. Okay. And if they do so, then competition will give them the price results that they're looking for. One of the nice things about dry process rubber is that it is cheaper today than polymer modification, which is one portion of the mainstream paving market in the US. It's cheaper, period. So there's money to be had, benefit to be had that will stimulate investment and allow these sorts of technologies to get adopted.
Thanks, Red. Let's talk about that performance head to head. Asphalt is not a monolith. It's not all one thing. There's different grades, different performance grades. There's different types of asphalt. Carolina, when we start to look at rubber modified asphalt against unmodified or standard hot mix and against the polymer modified mixes that Red was just referencing, how does RMA stack up? What kind of data and evidence has actually helped states move forward in this respect?
Well, if we talk about more traditional, I'm going to go back a little bit here, more traditional wet rubber technologies, we have proved through evaluation over the past 15 years at the ENCA test track here that they can perform comparable to polymer modified mixes. So that's, I will call that the low-hanging fruit. You know, it's something that is there, it works. We are looking at the cost. We already mentioned for some of these wet technologies, cost may be a constraint because people are looking at the cost that you're putting upfront, right? So I will call that they perform well. But more recently, I'm going to give you an example. In 2021, at the ENCA test track, we built a section that was sponsored by Oklahoma DOT with dry rubber. And we left the section for one cycle, and the section performed comparable to a polymer section that we had. So that was side-by-side comparison. The section was left in place. So right now we are monitoring the second cycle of performance of that section. And so far the section is looking really good, excellent performance. So we are pretty excited about the possibility that these dry rubber technologies can also compare side by side with a polymer that, again, it would be more expensive for the agency, for the contractors. Yep.
Bill, can you point to any lab tests and field metrics that help validate this?
Sure. I guess I talked a little bit about lab tests before, so maybe I'll talk more now about field performance. In that State of Knowledge report in 2021, we looked at like 350 journal papers and reports that were out there, and the evidence was pretty clear when you looked at it in some that when you compare rubber modified asphalt to neat asphalt, unmodified asphalt, it greatly outperforms it, somewhere from 30%. We've seen even like a doubling of life compared to neat asphalt pavement sections. And it's not just like, one example in the country. There's a few good examples out there, but you seem to across the board see extended life there. And when you go head to head with polymer modified asphalt, the most popular one being styrene butadiene styrene or SBS type modification, like they've seen at the test track. But as other people have reported in the literature, you see pretty equal performance. And, we built yet another test section in Missouri just a couple years ago, and we looked at rubber modified against different things. One was styrene butadiene styrene modified. We also looked at polyphosphoric acid modified, and the rubber modified asphalt, once again, both in the lab tests and in the field performance, is giving equal, and in that case, better performance even to the modified section. So there's quite a bit of data out there now. And so if you formed an opinion, or you're talking to somebody who formed an opinion back in the 1990s or
Right.
something like that, look at the newer data. The scene has really changed. Just the amount of data that we have has changed.
Right. Heather, how do you think about return on investment from the point of view of a contractor in thinking about your stakeholders?
Yeah, I look at it to the fact that we're grounded in the realities of the low bid process, right? So, if you are truly comparing two same performing materials. And I think that was what was key is the ground tire rubber performs the same as a polymer blend. If that's the case, then you should be comparing those two, and the low bid and the cost competitiveness of ground tire rubber could weigh out. But when you're comparing it to a mix, a conventional modified, not unmodified mix, conventional mix, asphalt mix, and there's a performance enhancement with the ground tire rubber, and if the DOT is not getting value to that, we're not going to add it in, right? Like there's no reason for us to add it in the low bid environment. So I think that's really important nuance is the agencies, when they're allowing their specs for these type of mixtures, that they're putting value to the additional performance or comparing it with like performing materials. And that will be important for contractors. I mean, contractors are going to respond to what their customers want. And so I think that is important. When it came to the ROI for the pilot projects and the equipment, our equipment, we used the dry process and it made use of other equipment that we had. I think it was the fiber. We use some where we blow in fibers normally. So I think there's some advantages with even the equipment and different additives and making use of what is existing at plants. So we didn't have an additional cost from the dry method.
Nice, thank you. Bill, for the state DOTs and engineers in the audience, service life and maintenance are other significant components of this value conversation, even in a low bid environment. These are perhaps, the service life and maintenance are perhaps undervalued compared to the initial install that often makes the decision. You've developed some cutting edge technology, a mobile system to map pavement degradation rates. Where are you seeing interventions or maintenance pushed out, and what early indicators should resource conscious agencies be tracking to help guide their maintenance and understand maintenance benefits?
Yeah, that's a great question, John. Yeah, I think in the past we have this idea that rubber modified asphalt extends life, but now with these new tools, they're like cameras and lasers and LiDAR systems that give a high granularity of a picture of what's going on like a vast road network. And what we're seeing is starting to give us clues about why it lasts longer. And one of the things that you always used to hear is that, well, if you have a certain type of interstate mix, like a stone matrix asphalt, which really is just hard rock with a high amount of really good asphalt binder, it tends to not crack as much. And when it does develop some light cracking, the cracks stay really tight. So you may not even have to put joint sealant on for a long time, or if ever. And the smoothness is retained. But there's a question of why. And so what we're seeing with these vision systems is, and I always have asphalt on my desk. And so this was the cracking test I talked about before. And you pull it apart, you can make a crack. So think about a crack surface. And I think what we're seeing with these camera systems is that, asphalt doesn't like to form a 90-degree like this. We don't build parking curbs out of it. We certainly don't build bridges out of it. It has a little bit of flow. That's what makes it flexible. But think about all the rubber granules, the rubber nodules at this crack face. Even if you open up a hairline crack, one thing is it doesn't want to go very deep into the pavement because that crack will be arrested by the rubber that's down here and the toughness. If you just get a hairline crack on the surface, and then you've got the rubber in there, which has carbon black, it's an antioxidant, so the pavement tends to stay less aged and darker colored longer. And then you have those rubber nodules pinning together the asphalt crack. And I think that's why the cracks are tending to stay tighter in the field. And so now we're starting to be able to compute other benefits beyond just, hey, the crack lengths are less. The crack severities are less. And those integrate into your maintenance and rehabilitation costs, which would then be lower when you use this material.
Thanks, Bill. Carolina, when you're looking at going larger scale, off the test track and into the interstates, for example, how do you think about the challenges in assuring quality control in these larger deployments?
Well, I'm going to give you an example. Currently, there is a lot, this past cycle, there has been a lot of interest with the dry rubber technologies. We talk about some of the reasons on why that is. So we have a number of test sections that are currently sponsored by different DOTs. We have a section from Arkansas, we have South Carolina, Oklahoma has a traffic continuation. So I think states are building confidence with the performance of these sections. And going back to what we've been discussing, we are helping them develop those specifications that will ensure the quality that they need with the confidence that that particular mix is going to perform good. So this I think will allow the contractors to have the option, once you open that specification, to use the dry rubber for different applications. I'm not going to get today into details, but those sections that are currently in place are not just dense graded mixes. We have gap graded mix, we have an SMA mix. So I think going back to that importance of having that specification that will give some assurance that what you're going to be putting is meeting requirements.
Thank you. Let's turn a little bit to environmental product declarations, which are kind of like nutrition labels, environmental nutrition labels for goods and products. And I think we'll get a better definition of that in just a moment. But let's turn to EPDs and their adoption. Heather, I believe 12 states and several cities, including Chicago, use environmental product declarations in their bid process now. How are EPDs used in accepting or rejecting bids, and what would a crumb rubber EPD need to include?
So you're correct. There are several states that are moving towards implementing EPDs for asphalt mixtures, asphalt being one of the materials that needs to supply an environmental product declaration. An environmental product declaration, for those that don't know, it uses life cycle assessment and it reports the environmental impacts from cradle to gate in the situation for asphalt mixtures, gate being when it leaves our plant for that particular product. So it's like a nutrition label, but the environmental footprint of your product. How they're going to be used is ultimately still being decided and evolving, but it's likely that they'll establish benchmarks, and that's what was previously, being rolled out, and expect industry to aim for lower impacts from these said benchmarks, right? So with the current asphalt mixture EPD program, we have data in there, and we use for terminal blended ground tire rubber, and we use the data set developed by the Asphalt Institute. There is a movement for getting as much primary data as possible, and primary data would mean that, we're going to get EPDs for asphalt binders. I know Asphalt Institute, they went through a process of looking at getting EPDs. It takes a while because, as I mentioned, it's a life cycle assessment. They must follow the same rules, which we call product category rules, on how we conduct that life cycle assessment. And so industry stakeholders, industry stakeholders, customers, they all come together to develop these rules, and that can take some time. So AI, Asphalt Institute, they publish their PCRs, so you'll start to see EPDs for binders developed. I'm not aware of any to date, but that's in the works. That being said, there is currently a data gap for the dry process techniques. So that's an area that still needs attention and development. So if, an asphalt mix contractor wanted to get an EPD for our asphalt mixtures using the dry process, right now that's a data gap, and we don't have a way to get that data in. And there's two ways that you can get data into the EPD program. One is through an industry average life cycle assessment. So that's a possibility, and that's right now what the asphalt mixture EPDs is using through AI's life cycle assessment industry averages, or through EPDs. So suppliers can publish an EPD themselves as well, and then it would plug into our EPDs. So the National Asphalt Pavement Association is our program operator and an excellent resource, Dr. Aman Mukherjee, there on handling our program.
So EPDs can be a prerequisite to a bid, an asphalt job bid in some states. Bill, how do these EPDs change owner interests in rubber modification?
Yeah, I think everybody senses it's coming. You know, the first thing you needed to do to get innovations, especially kind of sustainable innovations into pavements, is to show that you can de-risk it by having the balanced mix design. It's like, look, I'm going to put this in here, and if it passes the rutting test, cracking test, moisture tests, then hey, let's green light to build the test sections. I think the next motivator will be just looking at the environmental impact or the lessening of some impacts with innovations like rubber modified asphalt. And so, you know, some states, I do national work. Some states lead in durability. Some states do leadership in economical pavements. Some look at resilience. Some look at sustainability. And so one of my students who did a whole PhD on EPDs in asphalt was hired to go work in the Chicagoland area. So I know Chicago DOT, the Illinois Tollway, O'Hara, they're all building and getting EPDs for asphalt. And I can only speculate why. And one is I think they agree that it's a useful tool and it's coming, but it helps it, if nothing else, even if you don't have procurement with weight factors on that, you can still see what you have. It's like, well, you know, there's only so much time in the day. There's only so much tonnage to try new things. Why not look at economics, durability, and sustainability before you decide where to go next with your specifications and your materials that are allowed? So just looking at mixes and having a scored numerical way to evaluate, you know, if I'm making a mix that is good conservation, it's good for water quality, good for air quality, and so forth. Well, how much? You know, and if I'm choosing between alternatives, maybe you have a green alternative and the way we always do it. What if the green alternative gives you like more life at less cost? And oh, by the way, you know, we're conserving aggregates and asphalt, and like, why wouldn't you do that? So even before you have the procurement, having those scores and having that assessment is great. And I think that's why we're seeing cities and states still drive towards that.
Thanks, Bill. And the Tire Recycling Foundation is working diligently right now to try and get this data gap filled, so that down the road, as EPDs become more widely used, they can be readily prepared, consistent with the NAPA Emerald Eco-Label tool. So let's talk about real-life applications in a quick lightning round here. Can each of you give a quick case study to help us illustrate the versatility that we've talked about today? Rubber modified asphalt provides value across a wide variety of applications, from the urban corridor noise to freeze-thaw, heavy truck mountain routes. The whole state of New York is modified asphalt. Carolina, let's start with you. You're muted. I'm sorry.
Yeah, I was saying that I have to think for a second, because I say what of all the cases that we've seen so far, but one that I think is pretty interesting is one that we are currently evaluating, and so far the performance has been excellent. We have a section for South Carolina DOT, an SMA mix. So the idea here was, can we use dry rubber as a substitute for an SPS binder and also cellulose fibers? So you are replacing that dry rubber, you're replacing the SBS and plus fibers with this dry rubber. And we place this section. This section is looking excellent, really good performance so far. So I think we are pretty happy, and we are in the process of helping the DOT to open that specification, you know, to put it out there, because I think they are going to be, for what we've seen so far, we're going to be getting really good performance and a good outcome of what we put down there.
Excellent. Heather, what's one example that you've been involved with?
Since I already referenced the Wiregrass one, I'm going to talk about my previous life at FHWA, the case study with Puerto Rico. So Puerto Rico was looking at a policy where they were going to actually mandate, I think, ground tire rubber in all of their mixes for asphalt. And the reason they were, which I think was really interesting, was because they had a limited land space for and growing stockpiles of these tires that were creating mosquito breeding grounds. and posing fire risks. And so they were concerned with in finding other use cases for the tires. So there was, the testing from the paving side, which NCAT helped with on what was the mix design, what's the performance of their mixtures, what would that look like? And from FHWA, we looked at the life cycle assessment of that and what would that look like from that perspective with ground tire rubber. And what's interesting, if you looked from A1 to A3, which, in the case for Puerto Rico, we were comparing it to conventional mixes because they didn't use polymer modified mixes in Puerto Rico. So it had a higher impact. It had a higher impact because there was a little bit more binder in that mix, and we have the energy for recycling the tires. But what's important is that, A1 through A3, cradle to gate EPDs don't tell the whole story. They don't tell that performance. That's one issue. Two, they tell you your basic environmental impacts. They didn't tell us the environmental impacts from their true issues and the drivers of why they wanted to find uses for the tires, which was the mosquito breeding, right? Like there's other environmental impacts that are broader that aren't all captured in environmental product declarations. So what we did look, since we didn't have the full performance data, we looked at what would be that break even for if we were to take a conventional mix and the increased environmental footprint for the ground tire rubber mix, how many more years in pavement life cycle do we need where they would be about equivalent? And it was only 2 years, 2.3 years. So I thought that was a interesting way to look at it. Like as an agency, do I think I'm going to get a pavement life cycle extension of 2.3 years? And if I do with that ground tire rubber, anything beyond that it survives is all environmental gains, like your environmental improvements. And so that's what the study did find. But I can share that for you guys to share with the group, that the actual journal paper from the outcome of that study.
Excellent. We'll add that to the toolkit that we're going to provide after the session. Red, how about just a minute on a case study that comes to mind on a great real life use case for RMA?
We've laid many millions of tons. With respect to, all of the work that's been going on, this horse is out of the barn. We've got thousands of miles of interstate highways that have been paved, some for more than 15 years, with dry process rubberized asphalt. So it's out there. Georgia started this ball rolling with the modern dry process rubber. And essentially what they found was that it's comparable to polymer. They have millions of tons on the ground on their interstate systems, in their heavy traffic highways throughout the state. And, we're seeing other states that are replicating this process, not only in just that climate in the Southeast, but also in the northern plains, in the southwestern U.S., and the very far northern portions of the U.S. up by the Canadian border. So, case studies, there's a ton of them. I could go on for hours, and I won't, John. But the data is I think at this point simply that the states that have written specifications are not pulling back. Okay, they are allowing it to continue, and they're generating benefits as a result.
Thank you. And Bill, how about you? Quick application.
Yeah, I just go back to the I-70 test section that we have here in mid-Missouri, and the DOT, we had done state roads and some city roads, and they're like, let's go to the interstates to finally prove this out. And so we're looking at heavy-duty, high-traffic pavements, high speed. And they said, we need to know that if somebody hits the brakes in the rain, they're going to be able to stop. Is this rubber more slick, or is it have more friction? And so we hired a consultant to come from out of state to do the locked wheel skid trailer testing. And to our surprise, the skid number that we got for the rubber modified section was a full 15% higher than what they had been doing on the interstate. So that's a significant difference. And it means a shorter stopping distance. It could be the difference between a rear end collision and being able to stop safely in time. So that one jumped out at me recently.
Thanks, Bill. So as we wrap up a great discussion here, what recommendations would you have for the folks in our audience this afternoon in terms of what actions they should take in their positions, either as DOTs, policymakers, contractors, environmental agencies, owners over the next 6 months. Bill, how about you again?
I've thrown out a bunch of ideas there. Maybe something different is that I've worked on innovating other materials over the past 3 decades. And when you're trying to have new specifications or new trials in new places, I think just having all the data that you need before you start moving forward is key. And so I know that after this webinar, we're going to be posting a lot of information, but I've done a lot of workshops around the country in the past, just fly around, and nowadays you can do Zoom and stuff. I would say don't hesitate to invite, this panel or anybody from this panel to speak to your local folks about this, because we can just bring the data with us. We can do some things online. So just kind of going out on the line and volunteering all my colleagues here. But I think a group of us could probably sit down with an agency, and that I think moves things quickly at the beginning, rather than just doling through journal papers and reports.
Thanks, Bill. Carolina?
I was about to say something similar. Reach out. We provide. It's just as easy as giving a phone call. We will be glad to share any information. All our reports are available online. I just have to guide you through the right place where you can find them. I think also understand the possibilities. I will point out that again of having a performance-based specification. That opens the door to develop special provisions that will allow you to build those pilot projects that you're going to start learning from, and keep tracking the performance of those sections to gain that confidence that states actually need.
Heather?
So I summarized it into 3 areas: pilots, move towards performance-based specs, and lessons learned. I think you guys covered all 3 of them.
Thank you. And Red will give you the final word here.
Yeah, I think tires in asphalt roads, it's an industry opportunity. Okay, it can help your economics, dollars per ton in reduced cost, but it represents a strategic opportunity for the industry to profit long term through the use of an inexpensive commodity, tire rubber, instead of a manufactured chemistry. That's for the heavy traffic roads. It also allows you to use that same commodity to extend the life of other roads. Right now, markets for rubber and asphalt, they're popping up all over the US. And I would say more than 25 states now are in one form or another actively considering the addition of dry process rubber. In addition to that, there's a lot of states that still have wet process rubber specs in place. If your state's not active, reach out, talk to them. Whether you're in the agency or a contractor, start the dialogue, reach out for information. You've already heard the offer from all the people on the panel here. Me too. We'll be very happy to help you and provide additional data. There are going to be some resources, I think, provided by USMA and the Tire Recycling Foundation as a result of this effort. And share information that you get with your community, with your industry community. The more we know, the better we're going to operate over time. But at the end of the day, that this is, as I said before, this is a real opportunity, and it's not experimental anymore. We're out there. It's in widespread use in hundreds of plants, hundreds of projects. So time perhaps to step up and take a really hard look. Thanks.
Thanks, Red. We did get a question in as we went through our presentation that we'll get to in just a moment. And if any of our attendees have a question, please put it into the chat right now, and we'll get to them in just 1 second. I think this discussion really addressed the performance question and established that it is a high performance material. I think we addressed climate and that it can be used, rubber modified asphalt, in almost any climate option in the US. There's a variety of mixes that it could be used for, open graded, gap graded, dense, pretty much the whole range, stone matrix asphalt. And I've heard rubber modified stone matrix asphalt called the Cadillac of asphalt by some folks here in Illinois, where we drive on the Tri-State Tollway on rubber modified asphalt. One question about recyclability came up. I understand that when rubber modified asphalt is stripped up at the end of its useful life, it can be recirculated into reclaimed asphalt pavement. and the FHWA had issued an opinion saying it was fine for that purpose. Bill, are you familiar with recycling of rubber modified asphalt? Because that question can come up.
Yeah, I mean, no reason why you wouldn't be able to do it. First, can you grind it? So when you road a mill a pavement, do you run into any problems? You wouldn't. This material mills up just like regular asphalt. That wouldn't be the same if you put a fabric or a metal netting in a pavement. Then you got to deal with it. But this is just like milling up any other pavement. And where that reclaimed or recycled asphalt pavement goes back into, let's say, a drum plant, is where dry process rubber went in the first place. So you're just putting that recycled rubber in, and you might be injecting some new rubber modified asphalt at that time. So there's no real difference from a production standpoint there, but it's just, you're going to reap the benefit of the old asphalt and the old rubber, and add a little bit of fresh virgin binder and a little bit of fresh rubber. And you could just keep repeating that process. So I don't see why this shouldn't be completely circular process. I can't vouch for the rubber after 5 recycling cycles. I don't think it's going to hurt the mix. It'll eventually, the benefit will eventually decay, but it's going to be there a lot longer than the old binder itself. You lose benefits from the old binder pretty quick, but I think the rubber will hang on for many, many recycling cycles.
Oh,
John?
I've heard. Yeah, go ahead, Red.
Well, we're in the U.S. is in its fourth pavement generation of recycling rubber and asphalt. And 2 things, no issues, no problems that I have seen in the published literature that appear to be chronic. And secondly, Bill's comment is that after you reuse it multiple times, it just simply becomes part of the aggregate in the mix. Okay, well, maybe with some additional resistance to cracking, but you can recharge that asphalt mix with additional rubber each time you go through the cycle, depending on balanced mix design requirements for whatever mix design. So rubber has been used in pretty much any mix design you can think of. It's been used across a wide array of climates. It's been recycled. Remember, this has been going on really since the late 1970s, and we're not seeing any issues with recycling.
Well, I want to express my sincere appreciation and thanks to all 4 of our panelists for their expertise, and to our listeners for their time, passion, and attention. There's been substantial important work as it relates to growing and expanding ELT markets, and it's informative to have a forum where we can share the innovation and collaboration happening in one place together, because effective collaboration is the only way we're going to reach 100% tire circularity. Keep your eyes on your inboxes in the coming days, as we'll be sharing a post-webinar toolkit to help equip you even further with data, insights, and tangible steps to expand the markets in your areas of influence. If our audience has specific technical questions that we did not address today, or you're looking for additional expertise, please contact us directly, and we'll do our best to connect you with a subject expert who can assist further. I hope you'll join us for our next webinar in this series, which will take place in the new year on January 21st at 2 Eastern Time. In that discussion, we'll be exploring how rubber modified asphalt is gaining momentum across Midwest states. This next webinar will examine how Michigan, Missouri, Indiana, and other states are engaging in pilot projects, evolving state specifications, and driving government industry collaboration. Panel and registration information can be found at tirerecyclingfoundation.org. And finally, please take note of the Tire Recycling Foundation's 10th Tire Recycling Conference, which will be held May 12 to 14 next year in Denver, Colorado. Registration is open, and the conference is an excellent opportunity to engage with our esteemed panelists today and other subject matter experts. There will be sessions focusing directly on rubber modified asphalt. If you are an organization that wants to share information about your services or products, we have exhibitor opportunities currently available, and we also have sponsorship opportunities. We plan to continue these important discussions and provide further valuable information and insights in Denver, and we encourage your participation. If you have feedback on the webinar or additional questions for USTMA or any of our panelists, please reach out to Stephanie Mull at SMULL, that's SMull, at tirerecyclingfoundation.org. Thanks again, and we're looking forward to more ELT talk and RMA review in 2026. Thank you. Bye for now.
Thank you.